Now system, as we've seen before, can exchange mass or energy with surrounding. If the system loses energy, to the surrounding, that means energy is gained by surrounding, and vice versa. Okay, and if system gains energy, then surrounding is losing energy. So energy exchange, energy is being transferred between system and surroundings. What are the units of this energy? Units of energy. Very important unit of energy. Very important unit of energy is joules. 1 joule is 1 kilogram meter square per second square. Okay, very important. We have another unit of energy, calorie. 1 calorie is 4.184 joules. We also have a kilocalorie, written as kcal or capital CAL, kilocalorie. Kilocalorie is 1000 calories, or, and make sure to, for kilocalorie it is a capital case C, and for calorie it is a small case c. 1000 calories is 1 kilocalorie. There is also another unit, 1 kilowatt hour. This is 3.60 times 10 raised to 6 joules, and these are the important units of energy. Now, thermodynamics is the general study of energy and its interconversions. So, energy and interconversions, as in conversion from one form of energy to another form of energy, energy conversion from system to surrounding, etc. This is known as energy interconversions, and you study this under a broad topic known as thermodynamics. And the very first law of thermodynamics says that first law of thermodynamics says that total energy the total energy of the universe is constant. The total energy of the universe is constant. In other words, as there is no production, or more clearly, there is no creation of energy, no destruction of energy. Total energy in the universe will be same. Okay, total energy of the universe will be same. Now, going back to types of energy that we talked about two important types of energy: potential energy and kinetic energy. Potential energy and kinetic energy. If you add these two type of energies in a system, you calculate entire potential energy of all the particles, all the atoms of the system. Then you calculate kinetic energy of all the atoms in the system. In other words, you're taking a particular system, all the particles that are composing that system, you calculate the potential energy and kinetic energy, add them. What you get is known as the internal energy of the system. Internal energy of the system. Internal energy of the system. This is represented by capital case E. Internal energy is a state function. What does state function means? State function means that you look at the state of a system, initial state. Some initial state, it has a certain amount of temperature, it has a certain amount of pressure, certain amount of kinetic energy, certain amount of potential energy, all that. Then some reaction takes place and that system comes to a final state. So the internal energy depends on this state, or when you're examining the final state, it depends on the final state. No matter how it got to the final state, internal energy will not change. Whether it took this path or this path or this path. And one example, an analogy for this is in your textbook. There is a hill with several paths on the hill. There's a path that goes this way to this part of the hill. There's another path that goes this way to this part of the hill, right? So if one group of climbers start from here and go up to this point, and another group of climbers start from here and go up to this point. So initially they were at this altitude, finally they were at this altitude, and no matter which path was taken, they came to the same altitude. So in this case, altitude is a state function. Okay, so it depended on initial state and final state. So if you were to calculate the altitude, you will just say this height difference. So what is this height here and this height here, and what's the difference? There is no question of which path was taken for the climbing group to come to a certain height, right? So internal energy is a state function, which means that if you have to calculate change in internal energy, simply it is calculated as internal energy final value minus internal energy initial value, right? That's the way to calculate change in internal energy. Now if system lost internal energy, or if there was an energy flow from system to surrounding, energy flows out of the system into surrounding. Then delta E of the system, change in internal energy of the system, is negative, and change in internal energy of the surrounding is positive because surrounding gained energy. Okay, and then if system gained energy, meaning if the energy flow was from surrounding to system, then delta energy of the system is positive value and delta energy of the surrounding is a negative value. But in either case, the signs are opposite. Delta internal energy of system is always opposite in sign to delta internal energy of the surrounding.